Problem 64 shows an arrangement of capacitors like this, a 4 and a 12 microfarad capacitor and a 2 microfarad sitting in a circuit like this, and it's all being driven by a 9-volt battery. And the problem wants to know what's the charge and the voltage across each capacitor after it reaches equilibrium, which is, a few seconds or so after the battery has been connected. So what I do with this is just start breaking it down so I can maybe analyze where the parts come from. In particular, here's the 9-volt battery, which doesn't change throughout the problem. Looks like a capacitor, but it isn't. This line is shorter than that one right there. And the 4 and the 6 here are in parallel, so I can combine them into an equivalent capacitor here, which is just a 16 microfarad, because capacitors in parallel combine just by adding their individual capacitances. There's the 16 microfarads, and then going up here like this, and there's the 2 microfarads still sitting there. Now what I have is a circuit with a 9-volt battery, a 16 microfarad equivalent capacitor, a 2 microfarad, which is in there all the time. Looks like to me they're in series, so they can be combined into a final equivalent circuit that looks like this. This is still the 9-volt battery here. The 16 and the 2 will get combined into a single capacitor like this, and this is a 1.8 microfarad capacitor sitting like that. So this is sort of the sum-total equivalent circuit of the entire thing here, and just see the lineage of how it came down. First I combined the 4 and the 12 into the 16, then the 2 and the 16 into 1.8, and that's sort of what the net sum, the total circuit, looks like there. Okay, now we get to work finding the charges and so on. The reason why I need to go down to a circuit like this here is because I need something simple I can sort of work on and figure some things out about it. Now in particular, I have a 1.8 microfarad capacitor. Yes, it's the equivalent of the whole circuit, and it's a place to start. What can I do with this? I figure out how much charge must be drawn by the 1.8 microfarad capacitor. In particular, Q is equal to CV. So Q is equal to this 1.8 times 10 to the minus 6 times the 9 volts. So the charge I get there is 16 microcoulombs, about something like that. Okay, so what does that mean? It means that this 1.8 microfarad capacitor, when it's connected across a 9-volt battery, gets charged with 16 microcoulombs of charge. Why is that number important to me? Because remember, the 1.8 microfarad came from the equivalent capacitor of all of these things combined. So if the equivalent capacitor draws 16 microcoulombs, that's also the amount of charge that is distributed among all three of these capacitors. That's why we're doing it this way, so we can sort of get a handle on it. So we need to work with a 16 now. We won't go right up to the very top circuit. Let's go up to this one. Let's go up to this one right here. So I know that if 16 microcoulombs gets drawn by this capacitor, the 16 must be the charge that goes on both the 16 and the 2. How do I know the 16 and the 2 both get the same amount of charge? Because they are in series, so they must. So the charge on the 16 here is also 16 microcoulombs, and the charge on the 2 microfarad capacitor is also 16 microcoulombs. That's the way the result comes out. That's what it means to be in series if you're a capacitor. So if you wanted to know the voltage across either one of them, you can apply the capacitor equation once again. That says that, say, V on the 16 here is equal to Q on the 16 divided by its capacitance here. So the voltage on the 16 is going to be 1 volt. Where did the 1 volt come from? It has 16 microcoulombs of charge on it. It's a 16 microfarad capacitor, so 16 divided by 16 is just 1 volt, right? 16 divided by 16. The voltage across the 2 microfarad capacitor then is going to be the charge on the 2 microfarad capacitor, the 16 microcoulombs divided by 2 microfarads. So the voltage across the 2 microfarad capacitor is just 8 volts. There you go, and there you go. So this will be one of the answers here, because this is actually the voltage across the 2 microfarad capacitor, 8 volts and 16 microcoulombs. That would be one of your answers here. So in the original circuit, the 2 as it sits here, when it's all done, has 8 volts across it, and is charged with 16 microcoulombs of charge. We'll just continue back upwards in the circuit now. This one is sort of taken care of here. We know everything about it. How about these two? Well, I go back down here and I realize then that if the voltage across the 16 microfarad capacitor is 1 volt, where did that capacitor come from? Well, it came from the combination of the 4 and the 12. That means the voltage across this point right here, but across the 4 and the 12, must also be 1 volt. That's what I get with that right there. It should be 1 volt across those two guys like that. How did I get that once again? Because the voltage across the 16 came out to be 1 volt, but the 16 is the combination equivalent of the 4 and the 12. So there must be 1 volt across the 4 and the 12. That will be one of your answers here. So the voltage across the 4 will be equal to the voltage across the 12, which will be equal to 1 volt. That's an answer for the problem right there. What charge do you get? Well, if you know there's 1 volt across the 4, the charge that must be across the 4 then is just equal to its capacitance times its voltage. So 1 volt times the 4 microfarads. So I get the charge on the 4 is going to be something like 4 microcoulombs. That's one of the answers. That's the charge that the 4 microfarad capacitor will get on it, 4 microcoulombs. Likewise, the charge across the 12 microfarad capacitor will be its voltage, 1 volt, like the 4, times 12 microfarads. So the Q on the 12 microfarad capacitor then is equal to 12 microcoulombs. There's all your answers. There's the charge across the 12, there's a charge across the 4. The 4 and the 12 both have 1 volt across them, and of course the result for the other capacitor is right down in here, the 8 and the 16.